Okay. Look at this. We're going to solve by using logs, except for I want to just recall a few things. If I have log base b of b, that's going to equal 1. So if I have something like a 2x there, that's a 2y. If I have a 2 there, then this would cancel and it just leaves me with 2 times 1, which is just 2. So hopefully you understand what the heck I'm saying. If you have like log base 7 of 7 to the 3x, this is going to cancel out to just 3x because we can move this out in front, and then this part just becomes 1. So hopefully that makes sense. And we have that. Also, something that we can remember is that if we have just log with no base, log of x, that's the same as log base 10 of x. And this is actually on your calculator. When it says log, it means log base 10. And then the last one, if we have log base e of x, that's the same thing as ln, the natural log, ln of x. So there we go. We have those things. These two are easy to see on the calculator or use in the calculator. Some people have fancy calculators, but let's take a look at an example. So here we go. Anytime I want to get something out of the exponent, I can use a logarithm. It's nice. It's very nice. So this is what I'm going to do first. I'm going to pretend like I'm solving for this piece, which means I'll have to add 9 over and then divide by 7. In fact, actually, let's do that first. So I'm getting this piece by itself. So plus 9, and plus 9, and that would give me, what, 3? Those would cancel, and I just get 7 times 3 raised to the 8a. And then the next thing I would do is divide by 7, because I'm trying to get rid of that, and then divide by 7. Okay, that's pretty good. So now I'm just left with 3 raised to the 8a equals 3 over 7. And now what I want to do is take the log of both sides. That will help me get my exponent out of my exponent. I'll put it in front of the log. So take the log of both sides. You could actually change this to logarithmic form. 3 to the what gives you, but I'm gonna leave it like this. So take the log of both sides, log, and I'm gonna use base 10 so I can put it in my calculator, and then log on this side as well. And that's just log base 10. I'm taking the log of both sides. So what is that? Well, I'm not gonna plug it into my calculator just yet. I want to be sure that I'm getting everything. So, well, I can move this out in front. So I have 8a times the log of just 3, log base 10 of 3, and that's the log. Now I could change this to subtraction, but I'm going to put it in my calculator anyway, so I won't. And there we go. The last thing I'm going to do is going to maybe make you uncomfortable. I want to get a by itself, so I'm going to divide by 8 log of 3. And that will go away, and that goes away, leaving me with just a equals, and then log base 10 of 3 over 7 divided by 8 log of 3. Right? I should write it on the other side. 8 log of 3. And then I just plug this into my calculator. If you do that properly, you should get negative, so a equals negative 0.0964. And there you go. That's it. That's all you're doing here. So let's recap. Let's recap the steps. First, I got the 9 over because I'm trying to solve, like if I were to solve 3x minus 9 equals negative 6, I would get the 9 over. That's what I'm doing here. I'm pretending like this is what I have circled over there. So get the 9 over, and then divide it by 7. And then I took the log of both sides so I can take out the exponent. You could actually just do this, put it in exponential form, but then you have to use the base change formula. Maybe we'll see that. So there we go. Take the log of both sides. When you're putting this in the calculator, I think it's a good idea to put parentheses around the bottom part right there, just so that you can make sure that you're dividing by 8 and log base 10 of 3. So there you go. I'm going to stop this now.